now try to prove some theorems given in this chapter which we have been using to solve our problems. So the first theorem given is as follows. Any vector v in an n-dimensional space can be written as a linear combination of n linearly independent vectors ranging from 1 through n. So let us try to prove this theorem by the method of contradiction. So let us say if there would have been a vector v for which the above statement would not have been possible, then in such a situation we would have n plus 1 linearly independent vectors. So let us say we have this vector v and it cannot be written as a linear combination of just n linearly independent vectors. If we need another vector, n plus 1 linearly independent vectors if we need. So n plus 1 linearly independent vectors we would need if n is not sufficient. But from the definition of dimensionality, an n-dimensional space can have maximum of n linearly independent vectors. So, and this vector v is a member of an n-dimensional vector space. So that n-dimensional vector space can only have n linearly independent vectors. Therefore, our vector v would have to be written as a linear combination of n linearly independent vectors because the vector space itself cannot accommodate n plus 1 linearly independent vectors. So n plus 1 linearly independent vectors are not cannot exist in an n-dimensional vector space Therefore, our vector v would have to be written as linear combination of n linearly independent vectors. N plus 1 is not allowed. Thus, we prove the theorem which says that any vector v in an n-dimensional vector space can be written as a linear combination of n linearly independent vectors.